Good morning, friends. Welcome to this course, Manufacturing Technology Second Unit First Lecture 11, Material and Cutting Operation. Agenda for today present in this video: cast cobalt alloy, cemented carbide, and coated carbides and ceramics. These are material present in this video in very detail. High speed steel. These properties of this material, the vapor dip, vap, the poop vapor deposition, coating are the generalized done at a low temperature as the resultant of adhesions and the coating coating is the problem which is solved by the improved cleaning for the etching of the techniques used for this. The AISI steel types of the steels and the chemical composition of the material. The T1. T1 is the mention and consider for the name of steel for the carbon content in the 0.7% and chromium 4% and vanadium 1% and vanadium W is the 18% and molybdenum is the 0.9% and cobalt CO is the 12% and the V equal to 18% and T6 is the also mention of the material's name is the carbon composition is the 0.18%, 80%, chromium 4.25% and the vanadium is the 1.5% and W is the iron of the 1.5% and molybdenum is the 8% and cobalt not to the not contained in the cobalt and the V is the equivalent of the weight is the 17 the it 21.8% MiG and magnesium based of the material. Carbon contains 0.80%, and chromium 4%, and vanadium V is 1%, and VWW is the VW is the wave of the materials 1.5% and molybdenum 0.8% and this and the for the and molybdenum is other is the no contents for this iron and this is the VW is the weight of the 17.5% of the material. M6 is the also considered for the material. This is composition chemical compositions of the material is a 0.8 per 80% and chromium 4%, vanadium 1.5% and W is the 4% and molybdenum MO is the 5% and cobalt CO is the 12% and VWE is the 14%. Mg30 this is the also considered for material is mentioned for this is chemical composition is 0.85% of the carbon and chromium 4% vanadium 1.25% and W is the 2% and molybdenum is 8% and chromium is the cobalt CO is the 5% and W is the 18% of this material is contains for the M42. This is the material name of the materials is new composition. Is the carbon is a 1.10% and chromium 3.75%, and vanadium is the 1.15%, and W is the 1.50%, and molybdenum 9.50, and cobalt is the 8.25%, and the W is the 20.5% of these materials. Cast cobalt alloy. The cast cobalt alloy of materials, the powder metallurgy method through the casting is also used by some manufacturers. They contains they contains and these are the hardness even at the equivalent temperature better than the high stainless steel, high speed steel, and the consequently are used for the cutting speed higher. This is material is the metal cutting speed is very high, is the 25% higher than the high speed steels, and this is they have the higher toughness of the higher stiffness of the materials, and the the currently these are the beginning phases out since the carbides are now available which have a large and range of properties. Is the cobalt cobalt based alloys. The cobalt based alloy is the material is the roughing grade, and the composition of the first is chromium. These are the contents of the materials is the this is the chemical composition of the materials in chromium, vanadium, molybdenum, carbon, manganese, silica, nickel, cobalt. These are the composition in this cobalt based materials in composition. First composition is the first composition of the material is a chromium 30%, and W is the 4.5%, and molybdenum is the 1.5%, and carbon 1.1%. For Mn is the one magnesium 1%, and silica Si 1.5%, and Ni 3%. For rest of the all the cobalt, rest of the all cobalt and roughing, the grade of the material is this is a composite achieved for the roughing or roughing composite. Okay, the second is the general purpose or use for the cobalt alloy is general purpose. This chemical composition 30% chromium and 10.5% of W is the molybdenum is not contains for the carbon 1.7%, and manganese is the 1%, and silicon is the 1%, and nickel is the 3%, and the rest cobalt remainder cobalt. This is the composite or application of the general purpose of machines, and this second is the finishing tools. You make for the finishing tools. The finishing tools material is composition of the chromium 32%, and W is the 7.17%, and the MO is the not contents for the carbon, very high content of carbon 2.5%, and is the 1%, and silicon is the 1%, and nickel 2.5%, and remainder is contents of the cobalt. And this is the material is finishing operation is used for tools. The cemented carbide, this is our material. The cemented carbide. The cemented carbide are produced by the cooled compaction of the tungsten carbide powder in the binder. This is the use for the material are also used in the binder form, also followed by the liquid phase and centering operation. High hot higher hot hardness of the steel, and these can retain the hardness too much the temperatures, and as the resultant of casting speed use are the 3 to 6%, 3 to 6 time of the about the 5 to 6 minute per second. Then the high speed steel is also used. The cemented carbide to higher young modulus. The young modulus of this material is very high. This result in the stiffer cutting for tools, the less tendency of toward the cutters. However, the carbides are more brittle and expensive. It is the possible to vary the composition of the carbide to get a range of the properties. The variations achieved are based on the amount of the CO binder, different types of the carbide, and the grain size of carbide tools. The cemented carbide content present the usual composition of the straight great carbides is the six throat of the run for the carbon. Cobalt is the percent as the iron, 94% of the CW with the cobalt composition range of the 5 to 10% of the throat iron. Addition of the titanium carbide TiC increase the hardness. This increase the hardness and wear resistance and resistance to thermal deposition about to decrease the strength. The usual composition is about to 5 to 25% and similarity to the presence of titanium carbide. Titanium carbide increase the hardness of the resistance thermal deposition while the decreasing wear or resistance of strength. As the cobalt content increase the toughness, impact resistance, and the cemented carbide increase the while the hardness, young modulus, and the thermal conductivity of the decrease. Coated carbides, that's the server coatings and coatings and the coating for method have been developed for the cutting tools since in last 30 minutes within the about the 5 mm coating for the nickel and is has been used for the cemented carbide tools. Further, the good lubricating properties of the containing minimize the friction coating of the carbide. The tools tip of the tool chip and the tool workpiece the interfaces mm, thereby looking for the cutting temperature. All these translates into the lower layer forces and generated to the during the machining compressed to the uncoated tool. The life of the coating tools is two often the two the 3 times of the uncoated. While these are the use for the higher cutting speed, this material is the increase the productivity of the industry. These are also these containing such as the titanium carbide and titanium nitride, aluminum oxide, and aluminum nitride, and hafnium carbide to the multiple coating of the multiple coating of above for the deposit of the deposits for use carbide tools better than the chemical vaporization deposition. Chemical vapor deposition is the process in this operation used for the coating purpose. The coated carbide, the typical containing material used include the titanium carbide and titanium nickel and aluminum Al2O3 and titanium for all the materials used in the dam- diamond property of the some coating materials Ni nickel titanium nickels the room temperature of hardness of the 1930 to the 2200 for this and the and oxidation or resistance degree 600 degrees Celsius coefficient of friction 0.4 to 0.5% is friction is very high. The titanium TiCN is the room temperature of hardness on the hardness of the room temperature 2700 2730 say 3000 of the MHV number of the oxidation resistance for the 400 and coefficient of friction 0.3% and the Ni titanium and Ni is based for the room temp the hardness of the room temperature is the 3000 to 3500 and the oxidation of resistance in degrees Celsius for the 1800 degrees Celsius and coefficient of friction 0.0 and the nickel and Ni base for alloys. The coating of this material Ni the this is the room temperature hardness of the 4000 and oxidation or resistance 950 degrees Celsius and the coefficient friction is the less. Reminder the titanium has the CNM for this is the coating of the layer of the or coating of the carbide is the 32% of the room temperature of hardness and the oxidation of the 600 degrees Celsius for the coefficient friction is 0. Multiple coatings for generalize the provided higher tool life and offer for the broader use for the machining different work material for use. Ceramics is also used for the metal parts of the ceramics are the essential for aluminum Al2O3 based higher refractory material introduce the specifically for the higher speed machining of difficult to machining material and cast iron in view of the ability to the withstand high temperature they can use for the machining at a very high speed of the order this is the very high speed of the is what 10 minute per second 10 meter per second. Apart from the pure aluminum-based ceramics, sometimes other materials such as the titanium carbide (TiC) titanium carbide and titanium nitride (NiC) titanium nitride TiN and the di titanium dibroded for the TiB2 added to the enhance for the transfer rupture strength. The transfer and rupture strength hardness of the thermal shock resistance is also viscous or reinforced aluminum Al2O3 plus SiC are aluminum based ceramic tools that have mm, strengthening of the silicon carbide fiber about the 25% of added in the aluminum of matrix materials for also use ceramics is the silicon nitride Ni3 N4 base Ni and 34 based on the also used for the cutting tools materials these are good oxidation resistance and good mechanical strength and higher toughness hardness of the material This property of the ceramic materials is based on the Al2O3 and the density of the 3.98% hardness of the 25 5 degrees Celsius is 93.9% of, and the 1000 degrees Celsius of the hardness while is the 7.710, and the transfer rupture strength of the 550 megapascal, and the Al2O3 plus a titanium in carbide. Titanium carbide is composite for the density of 4 increase for the density 4.224 per gram per centimeter cube for the hardness of the based on temperature 94.3% and 100 degree 1000 degrees Celsius on the hardness is the 70 770 hardness of value. The transfer of options is 80 megapascal, and silicon Si3 and 4 by the silicon nitride the density 3.27% and the hardness of the is 25 degrees Celsius on 92.6 hardness or rupture hardness, and the temperature is also increased for the 1100 degrees Celsius. For the transfer of the rupture strength for the 100 megapascal, the coated cutting speed produce good surface finish, optimum productivity, and better tool life of these materials. Thank you so much.